In this video, we're gonna decode the standard polar conic form. So conics in polars are either r is equal to plus or minus e cosine of theta, make this p, e sine theta. E is your eccentricity, c over a. D is your, P is your distance from your focus to your directrix. And your focus is always at the origin. The center is not always at the origin. So if we have r is equal to 21 divided by 2 plus 5 cosine of theta, let's find the parts of this. 2 can be factored out. And you could move this 2 to the top. That would be r is equal to 21 over 2 divided by 1 plus 5 over 2 cosine of theta. Comparing this to our form, we see that E is equal to 5 over 2. EP is equal to 21 over 2. You need to solve for P. So you have 5 over 2 times P. We just substituted in this value here. So we took our E and replaced it here. And you have 21 over 2. Now P is equal to 21 over 5 because you can multiply this by the reciprocal. And that cancels out, so that's why that's our P. So we can see that our eccentricity is less than 1. I mean, it's greater than 1. It's 2.5. So that means that you have a hyperbola. Where is your center? Your center is not at the origin. Your focus is at the origin. Because it's cosine theta, it's going to open left and right. So our focus is at 0, 0. Our P is equal to our directrix. So X, our directrix, X is equal to 21 over 5. So we can see these are our features. Now let's do another example. Let's say that we have r is equal to 12 over 3 plus 2 cosine of theta. Now, if we factor the denominator, we're gonna have r is equal to 12 over 3 times 1 plus 2 over 3 cosine of theta. 2 over 3 cosine of theta. R is equal to 4 over, because you can divide 12 over 3, that's equal to 4. You have 1 plus 2 over 3 cosine of theta. Now we can identify our parameters. E is 2 over 3. EP is equal to 4. Now, E, we can plug that in, 2 over 3. P is equal to 4. Multiply that by the reciprocal on both sides. Now, P is equal to 12 over 2, which is equal to 6. The focus of this equation is going to be at 0, 0. And your directrix, because we have cosine theta, our directrix is going to be x is equal to something. because this is going to be horizontal. So that means that the barrier that you will have is going to be x is equal to something. That means it's going to be a vertical directrix. And our directrix here is going to be x is equal to 6. So we can actually put this here. That was a vertical directrix. Now, because e is less than 1, here, 2 over 3 is 0.67 approximately. This is going to be an ellipse. Now, if r is equal to 18 over 4 minus 3 cosine of theta, we can factor, this is our third example. So you have 18 over 4, 1 minus 3 over 4 cosine of theta, and this is going to be 9 over 2, 1 minus 3 over 4 cosine of theta. So after this, we can identify what our parameters are. So E is 3 over 4, EP is equal to 9 over 2, and if you substitute in E, that's 3 over 4P, which is equal to 9 over 2. Multiply both sides by the reciprocal. And P is equal to 9 times 4, which is 36. 2 times 3 is 6. This is equal to 6. Our focus is going to be at 0, 0. Our directrix is going to be x is equal to -6. And because E is less than 1, we have an ellipse. For our next problem, we are going to do r is equal to 10 over 2 plus 5 sine of theta. So you're going to factor this first. R is equal to 5 over 1 plus 5 over 2 sine of theta. You can identify your parameters. E is equal to 5 over 2. EP is equal to 5. So 5 over 2 times P is equal to 5. You can multiply this by the reciprocal on both sides. P is equal to 10 over 5, and P is equal to 2. Your focus, like always, is going to be 0, 0. And your directrix is going to be the horizontal line y is equal to 2. Because our E is greater than 1, we have a hyperbola. Now for our next example, we have r is equal to 15 over 3 minus 5 sine of theta. 15. So what you're going to do here is you're first going to factor out your 3. So that's going to be 3, 1 minus 5 over 3 sine of theta. And 15 over 3 is equal to 5. So you can rewrite that as 1 minus 5 over 3 sine of theta. Now, after this, you can clearly identify your parameters, where E is equal to 5 over 3, EP is equal to 5, and P, we can find this by plugging in. So 5 over 3 times P is equal to 5. Multiply both sides by the reciprocal, and we can see that P is equal to 15 over 1 times 5 is 5, and that's equal to 3. So we can see that in this problem, our focus is going to be at 0, 0, and our directrix is going to be at y is equal to -3. And because E is going to be greater than 1, we can see that this is going to be the equation of a hyperbola. So in general, when you have cosine of theta, this means that you have a vertical directrix, and it's going to be x is equal to plus or minus p. And when you have sine theta, you're going to have a horizontal directrix, and this is going to be when you have y is equal to plus or minus p. The most important thing to remember is that for all polar conic equations, your focus is always going to be at the center, and your equations, your polar conic equations are written relative to the focus, not center.